Another way of high volume roughing, plunge milling being one, is peel milling. Now, you can use the same tool, the Power Feed Plus, to do both, where you can profile, do 3D milling. You can step down at very small step overs and step downs and do profiling on the workpiece. You can actually take the same tool in plunge. You'll find these tools over in our booth. It's a very effective tool. It's nice to have a tool like this that you can use in many different ways, as opposed to being locked into, well, I got this tool to do this, but then I'm done with that operation. It goes back in the drawer till sometime I get another job where I can use it. Or here, because you're utilizing your programming expertise and the CAM programs that you purchased along with your machine, now that one tool becomes several. This is an example, by the way. You look at the fixturing. This is an example of working and partnering with one of our customers out west, where he had this very large, very lucrative contract dangled in front of him, and he says, the thing is, I don't have time with the workload in my engineering team. I don't have time to process this. Can you guys work on this? He sent us the parts and he sent us his fixture. This is being done in our tech center. We laid this out for him, and we handed him back a program and said, here, go cash the check. Plunging doesn't always involve a plunge tool or plunge mill. You can actually use any center cutting tool and go down and evacuate, say you're putting in a pocket. We have some great product in our drilling line now where you can go in and remove the majority of what was there taking up space and what becomes a pocket without ramping, without corkscrew milling. You can't really plunge unless you have an opening to start in with, because a plunge mill, imagine you've got a hole and you're opening it up in your yard. You just, dig a tree or whatever, and you take the spade, so you shave it open further and further on all sides. That's plunge milling. But if you want to go in from solid, you'll need to use a drill. Once you've got that done, you've removed the majority material. Now you get into the high feed machining. Remember, Bill's presentation here deals with high volume roughing, high cubic inch for metal removal. It was unheard of to think of a tool that small in diameter, so you think there's not a whole lot of mass there, not a whole lot of structural rigidity, and yet we're moving at hundreds of inches a minute. And by the time we're done, yes, we've traveled several miles in tool path, but we've gotten the job done quickly, more often than not closer to net shape without secondary operations or tertiary operations, and that's key. Well, this particular tool is one of our S-Max high feed. That's a tool that I'm more familiar with. It deals with the product line that I manage. 10-degree lead angle, pushes 10-degree bevel angle. It's actually an 80-degree lead angle because it's just down from the top of the tool. And it gives you this chip thinning factor, which when you magnify that chip thinning and you get your chip thickness, you're not so much dealing with what the cutting, what the program says you're at 30 thousandths per tooth. You want to actually get a 30 thousandths chip thickness per tooth, and when you figure 5 times chip thinning, you might be programming at 115 or 120 thousandths per tooth. This has become very popular out on the West Coast, where they do a lot of work at Boeing. Titanium, again, it's a kind of material that's going to take a very long time, but you want that to be done right. I know when I land, I travel quite a bit. I want to know that that landing gear is going to hold up on me. The thing about titanium and the super alloys, you can, as compared to a low carbon steel, you can actually vary your surface footage with low carbon steels from 400 surface feet to 600 or 700 surface feet. You can still stay in the game. You can change your chip load or your advance per rep from 3 or 4 thou up to 6 or 8 thou, and you can still stay in the game. When you start dealing with titanium, the window of machinability is very, very small. Minute changes have dramatic results. Now we're going back to that Formaster speed, the power feed. There's a whole series of high feed mills. These tools, you can actually go in and do the plunging with them, and then do the high feed milling machining afterwards. In this case, there's no reason to do high feed machining. It's a nice short extension. You don't have a whole lot of axial load that's going to push your radial load. It's going to cause tangential load. You don't have a lot of that going on. So it just pushes straight up inside. Another example of the plunge milling using a high feed tool. We try to make these tools as universal as possible. Machining centers. Okay, some considerations you want to understand. There are differences in capabilities. If you're 5'2", you're not going to dunk the ball, and if you're 6'9", you're not going to fit into a small box like a little guy would. You got a Cat 40, you're not going to be able to do some things you can do on a Cat 50. But that doesn't mean you should just give up and stay in the little comfort zone, or send it out to somebody else to do, or be comfortable with not being productive. We have processes that we can bring to your shop that'll help you utilize that Cat 40 in ways you never thought of. What we'd hope you'll do is call one of the Ingersoll sales professionals in, and we can work with you to do that.
Bill Fiorenza, Ingersoll Cutting Tools. I'm going to pick up here where Mr. Noble left off here, but machining considerations are very important. Rigidity of your machine, obviously, a lot of you gentlemen know this. Be your machine base design, your control, very important. Look ahead features, things like that. But for plunge milling, not necessarily hugely important, although the base design is very important. Tool algorithms or cam algorithms for plunge milling, right? Plunge milling has been around for quite a long time. 15 years back, people were plunge milling, 20 years back, but it's becoming more prevalent in industry, okay? I used to be a programmer for a very long time, lead programmer for 2 mold shops. I programmed lasers, VMCs, all kinds of things. This is a great way to remove material. But with some of the newer algorithms, there's plunging algorithms built into most of the higher-end cam systems. And we have a part here, and you can see we've generated some tool paths with a progressive step over, right? Okay, now we're utilizing a stock model condition. Very important when plunge milling. If you have a stock model available to you in your cam software, whatever you're using, Power Mill, Surf Cam, Work NC, any of those, there's many more, Master Cam. A lot of them have stock models. It's very important to know in plunge milling where your stock is, okay, especially when you start doing 3D contour type work and roughing, things like that. Basically, you can see that previous program, we generated that tool path, and we're just plunge milling out this area here. Nice wide open area. You have some convex shapes. Plunge milling, as Tom might have mentioned, all the axial forces go up in the Z. This is a good thing. Example of plunge milling. Great way to remove material. Basically, we're just going into y-axis, right? This isn't rocket science here. You can see we're 23 inches a minute. Depth of cut, we're taking out 1 inch. 1146 RPM, 600 SFM. Another great benefit of plunge milling, if you guys work with high temp alloys, okay? Done it many times myself. You can walk over to this block. This is 4140 or 4340. You come over here, when this is done, you can put your hand right on top of it. You can also do that with stainless steel. Okay, a plunge mill stainless steel, you don't want heat to go into your block, right? Great way to prevent that from happening. Insert wear in the cutting edge is very, very predictable. Okay, and if you're a manufacturing facility or a job shop, you do 2, 3, 4, 500 pieces or 500 lot batch a month. This is a great way. You can chart this process very accurately. That's what's nice about it. You get very consistent results. So what we've done here is basically just pop a channel through the block, and then the next operation. And then you follow up with your favorite high feed milling tool. Okay, and you rapidly come around and you take the part to net shape. This here is a 7 effective 2-inch high feed mill, cooking along at 319 inches a minute. Okay, so roughing is where you're going to save the most amount of money, in my opinion. Your roughing process. Finishing is finishing. Semi-finishing is semi-finishing. You can get a little aggressive with semi-finishing, but where you're going to make up most of your time is in your roughing. So when you're looking at parts, look at them with an eye towards plunge milling. You want to take and envision the part, nice wide open areas. .400 inches a minute here. 30 thou depth of cut. That's bringing the part into net shape real quick. Okay? You see the snapshot of the control there going at it. I am going to take time. If you guys got 1 second, I know you've been patient and you've been listening. And there you go. You have a roughed out part very, very quickly. If you're not sure you want to get into the plunge milling and you just want to dip your toe in the water, utilize an Ingersoll quad drill for roughing out your pockets, right? It's center cutting. You can take a 60 to 70% step over, radial step over. We have 3 and 4 times D cutters. It's a great way because it's center cutting. If you do a little boo-boo, you're still okay, right? Basically, that's what it amounts to. If you're just trying to get your process down of how you're going to attack parts in the future, and it'll come natural. Study the part to be machined, identify areas of potential high volume. I mentioned that already. Weigh available processes and available machines. Understand programming capabilities. I still program today. Programming is everything. Okay? That is a huge thing with plunge milling, Z-level roughing, corner picking, whatever you guys are doing. Huge thing. Chip evacuation and control and management. Another important thing you guys understand. Chip packing. When you're plunging, one thing you got to be careful, especially if it's an inboard pocket area, is you got to think about how the tool's going to go around so you get good chip evacuation, because that can be a problem. A great way to do that is to start, if you get creative in the center, you drill a hole and then you come and you actually spiral out into a pocket. That's a great way to do it. And your chips, there's plenty of room for your chips to get out of the way. Determine and understand the capabilities of the next tool. That's a huge thing. Kind of look at what size cusps are going to be left in the part, and that's what's neat about the stock model too. The stock model will show your cusps accurately. You'll be able to see all those things. This was an interesting project here. A defense contractor down in Arizona. I personally went down there and we worked in this operation at Ingersoll and Rockford and down in Arizona. And when we were done, we ended up being able to rough 2 parts to his 1 part that was previously doing, the same amount of cycle time. So it's a great way to increase productivity. And the cam system, this is huge. You can do some really cool stuff, guys, if you learn how to offset splines and work out, especially on core applications. Okay, anything with a convex shape, that's a huge tool in your cam system. I encourage you to look into that. And then you just point the splines and you're good to go. This little chart here, plunge milling, things you need to know: part, your machine, your tool, your software, tool path, hugely important, feeds and speeds. That's if you can program a drill, you can plunge mill, right? Programming is everything.